I want to do another example. Let's look at find the Maclaurin series for the function, let's say, x squared cosine x. So the way we did these before was we made that table that I was talking about. So let me set it up again for you. N. And then you take the nth derivatives of your function. And this is a Maclaurin series, so what's my a value? 0, so we're going to plug in 0 to those. And then the final column is your coefficients. All I got to do is divide by n factorial. Okay. So let's start. I usually go with 0, 1, 2, and 3. So I go column by column, right? Now I'm going to take derivatives. So I start with my function x squared cosine x. And I need the derivative of that function. What's the derivative? 2x cosine x plus product rule x squared sine x. Okay. And then to get the next line, we take more derivatives.
Why is it plus?
Oh, minus, yes, minus, thank you. Minus. Okay, great. And remember, we just keep taking derivatives and derivatives as we go down. So then we would have to take a derivative of this. Each one of these is going to be a product rule, so I'll have 4 terms. Then you'll do it again. Do you really want to take these derivatives? Hopefully you're shaking your head no. You're disgusting, right? So, sometimes we can do a little bit of a shortcut, so we don't have to take all these horrible derivatives. So let's, because I don't want to continue taking these derivatives, let's look at our function again. So I'm going to write it down here. F of x, x squared cosine x. Now remember, when you're writing the Maclaurin series, I'm trying to write this function as some coefficients Cn x to the n, right? So I'm trying to get these polynomial terms, x to a power. So if you look, I have x squared in the front of my function. This is x to a power, right? So we're okay with that x squared. What's really problematic is the cosine. So a shortcut is we write down the power series for cosine and then multiply that by x squared to get the power series for this function, the Maclaurin series. So we talked about that, I think, the end of class on Wednesday. We found the Maclaurin series for cosine. So maybe I'll write. This is equal to n equals 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. This is the Maclaurin series for cosine of x. And so for my function, it's x squared times cosine x. So all I'm going to do is multiply that by x squared to get my f of x function. F of x, which I said is x squared cosine x. Now replace cosine x with its Maclaurin series, which is right here. The sum from n equals 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. So the only thing you have left to do is inside of this series, you're adding a bunch of stuff up. And so you just need to distribute this x squared inside, bring it in. So bring in this term, this x squared inside here. So you're getting the summation from n equals 0 to infinity, -1 to the n. So you have x squared here. And you can just combine your x terms. You add their powers together. Why does it keep doing that? You combine their powers together to get -1 to the n, x to the 2n plus 2 over 2n factorial. And this is your your Maclaurin series. Okay. So it's very special that in front of this cosine of x, we had x to a power. Okay. If you did a Taylor series where it's centered at a, you would have to have it x minus a. Okay. Okay. So sometimes it's a little bit shorter. You don't have to do the table every time, but you do have to rely on our previous knowledge if you're not going to use the table.